Okay. Mhm. Exit ಆಗಿ ಮತ್ತೆ ಲಾಗಿನ್ ಆಗಿ.
Small welcome of the name mutual. Good evening, honorable members of INSTRUCT. Today it's a fantastic evening because we have all senior members of INSTRUCT come here on physical presence for the regular flagship program of the INSTRUCT Need of the Hour. This series, both online and classroom sessions. Today, we are doing a seminar on structural condition assessment and retrofitting measures, lecture by Dr. Y.K. Guru Prasad. So on this occasion, I request our Guru and structure legend, Mr. Umesh Biraj, sir, to occupy the chair in presiding over the function. And I also request the guest for today, Mr. Y.K. Guru Prasad, sir, to come and occupy the chair. And today is also very nice evening at another professional body, ICI chairman, Mr. H.R. Girish sir has come. I request him to come and please, sir, it is a very nice situation because you also served INSTRUCT for a long time and now. Thank you, sir. Please take your seat. As we all know that civil engineering profession is taking a very, to some extent, at crossroad level, because for the last 2 days I had been to about 9 to 10 colleges where all the HODs are worrying about nobody is coming to college for joining. A civil engineering profession is becoming slower down, and some of the colleges have been closed their branches also. At this juncture, it is on the part of our duty. We should create awareness among the civil engineers that civil engineers are the kings of all engineering. So it is a major core branch wherein which we don't have to worry for our livelihood, provided we work hard and go for a longer way. So at this juncture, the Instruct has arranged this Need of the Hour program. I, on behalf of Instruct, I welcome HR Girish sir for this evening lecture. And on behalf of Instruct and the senior members, I welcome Umesh Birao sir in his valuable time. He has come. I request the Ullas Prabhu sir to welcome the chief guest and faculty of the program, Mr. Y.K. Guru Prasad sir, to this evening lecture. And without the honorable members who are all present online, I've seen many of the senior professionals, structural engineers, and of course, Instruct members, ex-officios have also joined in online. I welcome all the senior members who are here on this evening, and also physically, without naming individually, I welcome all the engineering fraternity who have come over here. Welcome to every individual who have come for this wonderful program. Now I request Ullas Prabhu sir to give a small introduction about Y.K. Guru Prasad sir, which would be. Yes, I request Umesh Biras to give a small brief about Instruct. Please, sir.
Thank you, Vajarat. It was when Mr. Nagbhushan Rao, who was managing director of Hindustan Construction and who started the NICMAR course when he was with HCC, he retired and he came to Bangalore. When we were chit-chatting, myself, Nagbhushan Rao, Nanjan Swami, Prasanna Kumar, it was just the dilemma still continues to be the same, and I'm sure it has been there from Socrates' days. It's nothing new. That irrespective of the qualification granted by the university, the knowledge level of engineering for the construction industry is minuscule. And hence, Instruct was started essentially to start certain courses or certain lecture series to make people understand what has been taught in the colleges. And when you come to the live project, how do you really apply? How do you really think of what you have already been taught? Our focus was not really on engineering as such, because we presume with the qualification university have granted, the new engineering. But with that, it started, and I must recall the first lecture of Instruct, I started with it of RCC design, and when we floated it, there were only 2 participants on the first day. But nevertheless, Mr. Nagbhushan Rao, Vishwanath Rao, they said, Umesh, we have to go through the program. And we went through, and I was so glad. By end of third day, we had 35 participants in the same course. They said, this is a different way of looking at what was taught in the college. And that's where Instruct started its journey. Our tagline has been there, enforcing the construction workforce in India. We need to elevate them. We need to allow. Colleges have their own duties. They have their own domains, and they have their own spheres. But when you come to the industry, the spheres are much larger where you need to apply. And how do you really apply what has been taught to you is what Instruct does. It's been there now almost 35, 36 years. We have done about 1,500 programs so far. It almost amounts to 1 program every week. Idea was, it's not that how much you know, because all of us have our upper bound theories and lower bound theories. Please come, share and be a participant as a resource person to address conduct so that the others could learn from your knowledge level of application. We have giants over here sitting. We have Abdul, we have Raghunath, I'm sorry, Professor Raghunath. I'm sorry, the familiarity brings me so close, I forget to sometimes give a prefix. It doesn't mean very. They're also knowledgeable over here from the field, and field being so large, we require, I'm very sure, we can conduct every day one program, and all of us, all being civil engineer, we are from so many different fields, and there's so much to disseminate. So on behalf of INSTRUCT, my request is, it's a mission. We do not have a yardstick of failure or success, neither in terms of money, nor in terms of participant, nor in terms of programs conducted. Our whole goal is to disseminate the information, try to teach as much as we can so that people who want to learn can learn. And we would continue with this mission of each one, teach one, whatever you know, please teach, please come forward. INSTRUCT requires resource person from every field. When I was talking to Manor, he said he was in execution. I'm sure, irrespective of the qualification, execution is a very different kind of fish. I don't think qualification, you require an attitude, you require a mentality, you require an entrepreneurship. There are very different kind of things, attributes which are required. With this very brief introduction of INSTRUCT, I request those of you who probably are not members, please do become a member. Please come forward, suggest the topic that you think INSTRUCT should carry over as a 1 hour program, 2 days program. We can do international program, which we have done it recently also on a very large scale. Help us. We require volunteers. We require resource person to disseminate knowledge. Please strengthen our hand, and that's an appeal to you. Thanks, Manjunath, for giving me an opportunity.
Thank you, sir. Thank you. Wishes from our Girish sir.
Thank you, Mr. Manjunath and the INSTRUCT team. I think I just recall the reason why Century Club was founded and constructed by Sir M. Vishweshraya. Because he saw that everybody were very busy in their respective domains, maybe the academia or the industry. So what Sir MV sir did was that just going about our work on a day-to-day basis is not sufficient. We have to constantly upskill ourselves. And that is the very basis why he found the Century Club, only for the purpose of exchange of experiences and empowering our body of knowledge to be applied for higher applications. Likewise, these type of gatherings, I would like to really say that I commend INSTRUCT for organizing this, and the peer organizations like ACC and ICI are also very close-knit. We complement each other. And I think this is the way to go. Going forward, we should also find solutions to perhaps one problem like the academia struggling with the admissions in civil engineering. And like Sir Umesh Rao sir said that even the practicing engineers, sometimes on the job, they need to upskill. They have no other way to go. Their companies may not have an upskilling program. So we in ICI or INSTRUCT or ACC or IITR, we have got a very prominent role to play. And this is not something like nice to have, these type of gatherings. I think it is a must have. Every now and then, at least once in a month, it should be like continuing professional development programs, which are mandated in every membership. I think shortly this should also be done so that we get to share our knowledge from erudite speakers, and we go ahead and upskill one and all and address the solutions and come up with the solutions to the society. I think that is the purpose of all this. I thank you and commend you once again, and thank you all.
Thank you, sir. Now I request Ulas Babu sir to give a brief introduction of group processor so that we'll continue with the lecture.
Yes.
Good evening to everybody. So it's a privilege for me to introduce Dr. Y.K. Prasad. And I think all of us should be proud that he passed out from BMS College of Engineering, Bangalore, and did his master's from MS Ramaya Institute, and then went on to the Indian Institute of Science to do his doctor's, all in structural engineering. Friends, he will be delivering today on assessment of conditions in the structures, a very important factor today. Various cities in the country have gone over a period of time, and people like him were very important, vital to look into the structures and also suggest various measures, retrofitting, as he says. So it's a proud moment for all of us here in the institute, as also outside, to listen to him today evening. Dr. Y.K. Prasad finished his doctorate from a course at University of Edinburgh, is it?
Part of my PhD work, I did it at University of Edinburgh.
Edinburgh, okay.
Basically, I completed my PhD from Indian Institute of Science.
Yeah, that's right.
So part of for a very short period of time, I was working at University of Edinburgh on a UK ERI exchange program.
Exchange program, right. So, and the areas of work and research are repair and retrofit of structures, repair adopting FRP components, structural health monitoring, non-destructive testing, evaluation, earthquake resistant design of structures and structural dynamics, finite element analysis, fracture mechanics, thermal analysis of concrete and reinforcement steel, microanalysis of concrete and reinforcing, structural analysis and design, biomechanics, and carried out consultancy works in NDT. Right. So he is also a reviewer in various journals and a member of various organizations. So let us now hear Dr. Y.K. Prasad. Over to you, Prasad.
Thank you, sir. Yes, I think I should. PowerPoint ಹೇಗೆ ಹಾಕ್ತೀರಪ್ಪ? A very good evening to everyone. A very good evening to all the dignitary members of INSTRUCT, to all the participants, to all the professors and practicing engineers who are present here. A very good evening. I'm Dr. Y.K. Prasad. I work as an associate professor in Department of Civil Engineering, BMS College of Engineering. And today I present my work on structural condition assessment and retrofitting measures which are applied in structures. So basically, to run through the contents of my presentation, I would be talking on condition assessment of structures. I would be talking on what are the basic modalities one has to go through while doing the condition assessment. It may be from documentation to the fieldwork which comes into action. Sources of damage in RCC structures. Well, even steel structures is also there, but for the talk of the day, I have considered RCC structures where we have also in steel too. But for today's work, for today's talk, I have considered RCC. Assessment of damage in a structure and its members. How is the assessment done? what all are the modalities, and how do we assess the damage and identify the damage, repair and retrofit measures to restore the stability and strength in distressed RC structures, what are the repair and retrofit techniques which are considered. Then coming to case studies, I'll be presenting a few case studies which has been taken up and worked upon also, which I'll be presenting it very briefly, and basically the conclusion of the talk. Coming to what is condition assessment, that is basically what we have to do in a structure. Why do we have to do condition assessment? Basically is examination of the structure and the structural components are one of the key points in condition assessments are examination of the structure and the structural components. Basically, it goes on from the structural plan. It may be the general arrangement of beams and slabs which are done with the column layout, including the foundation drawings which we have. From there, we start off with and identifying and defining areas of distress which we come across in the structure when we go across the examination of the structure and its components, basically. Recording history from inception to completion and subsequent life of the structure. That is one thing which we have to, it's basically a bookkeeping which the engineer has to look into. To identify the cause of distress and sources of the distress or the damage. That is the most important point one has to look at. To assess the extent of distress and damage that has taken place due to various reasons. It may be due to corrosion of reinforcement, due to a fire which has taken place there. It may be because of an earthquake or any other reason. It may be also due to a damage due to error in design too, which I'll be coming across in the later part of the presentation. To assess residual strength of the structure and its repairability, what we call it as a repairability quotient. Prioritize the distressed elements as per seriousness of the particular distress which has taken place. Basically, how serious is the particular damage? If it is not a structure, but first of all, if it's a partial damage or a damage which requires immediate concern and a remedy which has to be given. To select and plan the effective remedy for the retrofit. One has to look into that. We have to design the retrofit and also to choose the right retrofit measure and the materials which are required. Now, giving priority to the distressed or damaged structural elements according to seriousness for the repair. What is that which we require? How do we go about this? That is to what is the first priority? Which structural element is badly damaged and which needs immediate attention, which needs to be restored immediately. It may be the column, it may be part of the retaining wall, or it may be part of a beam or a portion of the slab. If it's in a position which requires immediate support, and what should be done after to that. There may be other parts of the structure which are damaged based on the degree of damage, which I'll be talking about, which needs immediate attention. For that, how do we do this? Basically, it's a preliminary inspection. A planning is required for that. How do we go about also doing the inspection? From which point we start for the structure and which point do we end? That is most important. Visual inspection, field and laboratory testing of maybe I'm going to talk about. Field and laboratory testing here also refers to the NDT which we are coming up to, and semi-destructive tests which we come up also. History of the structure from the client, owner, occupants, or general from the particular people who are occupying the building, if it is a general public in the building, if it's a government building too. Records of previous repair histories and expenses done for the same, if there were any, that has to be noted down. Basically, I'm talking, the beginning part of my presentation is going to be basically how we are going about to document everything for the condition assessment. And then we are going to go with the technical part of how we are going to do it in the field directly with the methods. So all possible data and information to be taken down, practical restrictions and survey and safety requirements for the survey team who go for the condition assessment. Because there may be some portions of the structure which may be restricted, where we may require permissions to go in. There may be environmental concerns, and there may be portions of the structure which may be so badly damaged where you require safety requirements if it's a fire damaged structure. So we cannot just go and inspect it as we do it for a normal structure too. So in such cases, what are the safety measures which we have to take apart from what we use the helmets and other yes, the requirements. Apart from that, what is that we have to take? There may be cordoned off and restricted areas where we cannot enter, and what would be the other measures which we can take? That we have to look in from this point of view. So then extent and quantum of survey work required. How much portion of the structure needs to be surveyed for the condition assessment? Is it 100%? The entire area, if there are so many floors there, how many floors have been damaged, and in that how much amount of the area needs to be assessed? All this from also a engineer and a client requirement also. I want to make it very clear, because there are cases, I want to put it across, where after the assessment is done, the client also says that there would be only this much requirement needed, and if the survey is done for a larger area, there would be also a problem with respect to the payment point of view. I would be very straight with this. So from that, as well as the manpower required also, based on the amount of manpower required, the number of engineers and the people for help whom we require, also we need to assess based on extent and quantum of survey work required. So time required, that is survey, and from survey to execution, this needs to be clearly at least assessed. We should have an assessment on that. Advise immediate safety measures. There are some portions where we have immediate props need to be provided. So that some places where the beams or the slabs are sagging because of various reasons of the damage, if we have to provide props or supports at the immediate requirement, this needs to be provided. That's the reason I said advise immediate safety measures where it is required. Period of construction needs to be known. How old is the building? Construction details, drawings, architectural, structural, all of them need to be collected. If not, if the building is very old, it's a very old building, it may be a heritage building, maybe the case of, I will talk about it in the later part of my presentation too. It may be a monument structure also. In such cases, when we don't have the particular plans or we don't have the structural details, we may have to do the assessment by measurement first and then go with NDT, and in case only required, go with semi-destructive tests to find out what is the type of material which is required to build the particular database of the particular structure. So coming to this, sorry, exposure conditions need to be considered. Where the structure is located. If it's in a place like Bangalore, it's okay. But if it's in Mangalore, it's in a saline environment. Or if it's in Bombay, or if it's in, you have a place like in Kerala near Trivandrum. So where is this present? Or it's in Rajasthan, it's a much hotter place. And or if it may be somewhere near Nainital also, I mean to say where there is most of the time, or places where it is raining heavily also. All these exposure conditions need to be taken into consideration, environmental conditions. And also if it's a structure, if it's located in a chemical bound environment, if it's a chemical factory or if it's in a chemical bound environment, that also needs to be taken into consideration. Design and present use of the structure. What is the present use? What is the occupancy type? If it's residential, commercial, mercantile, what it is at the moment, what it was designed for previously. Because what we see in today's date, people design it for a purpose and later use it for a purpose. It happens in our cities too, where it is designed for residential purpose, where we take most of the loading as 2 kilonewton per meter square as a floor load, but later it is rented out for commercial purpose, where we have it up to 4 kilonewton per meter square, which we come across. I'm just giving that as a small example, I'm sorry. Previous changes in use, both go hand in hand. Record of structural changes, if any, done. This needs to be very carefully done, because I've seen in many apartments, some places they have removed some portion of the structural members for various requirements of the occupants. Record of first occurrence of defect, if it is available, it would be really good, or based on observation from the occupants. Details of repairs carried out previously, if there are any. Previous reports, if any. Details of from owner and photographs is the most important thing when we go to the site inspection. Now, field documents are required as such. This is the planning survey. This is part of the planning survey. Field documents is something which we need to procure. Basically, on what is the type of buildings which are available, what exists around the existing building too, and what type of location it is located to in. Plans and actual observations. Room wise, I mean to say room wise, I put it from a residential point of view. It may be any structure based on each segment of the building, if that is taken into consideration, plans and actual observation from each room wise or each portions of the building. Previous reports advise if any and implementation done as per the report, if it was being done. Grouping of structural elements, external and internal needs to be done basically. If it's the number of beams or the columns, whatever that needs to be addressed to for the assessment as well as for the repair or retrofit conditions, that needs to be grouped. Exposure conditions, as I spoke about earlier. Now, classification of damage. How do we classify damage basically? So based on degree of damage taken place, we can go for to do any kind of repair or retrofit strategy. So basically degree 0 or 0 degree damages, no damage, but non-structural repairs, that is non-structural damages which have taken place. Especially it's like what we have as the plastering cracks because of shrinkage which would have taken place. Degree 1 minor exterior repairs which require. Degree 2 medium repairs like patch repairs, minor structural cracks. Degree 3 principal repairs, spalling of concrete cover, structural cracks along rebars. Degree 4 is major repairs, replacement of structural members itself in such cases. So what do we do in that case? So based on this degree of classification on degree of damage, we go ahead with further investigations with respect to the what type of retrofit or repair that can be considered. Now the next part comes based on, it is assessment based on the damage, based on the assessment, based on the inspection and observation, the damage level of the selected buildings may be categorized as shown below. One is the degree of damage. This is based on assessment A1, how we are going to assess the damage in a structure. When we go in, we are going to have a bookkeeping A1, A2, A3, that way. So when we come to that, A1 is no damage observed, A2 is minor damage observed. Let me make one thing clear here, is there is a clear demarcation between the degree of damage and the assessment of damage which is done here. Here it was basically you are classifying the damage, whereas here we are going based on assessment of damage assessment, based on we are going to number the damage basically. So A2, A1 is no damage, A2 is minor damage observed in few structural members, A3 medium damage observed in few structural members which can be repaired, rehabilitated, including strengthening with advice of a structural engineer. A4 is severe damage observed in some of the structural members which can be rehabilitated, including strengthening with the advice of a structural member. A5 severe damage is observed which could prove dangerous, hence evacuation at an early stage is required. This needs to be clearly put on the papers. So if this is put, it is very clear. It's like you're giving your assessment there. Is this repairable, retrofitable, or if not, it has to be evacuated and other measures needs to be taken later if any portion of the building needs to be pulled down only when there is a requirement. Sorry? As you say, sir, I can take it on the way, or I'll take it in the end too. Yes. Yes. No, this is to just, this I have just put it from the understanding of degree of damage. So basically the degree of damage which we come across, I'll be talking about it later, where the degree of damage can be, for example, it can be 20%, 30%, 40% of degree of damage, or assessment based on that will be on A1, A2, A3, A4. So based on that, I correlate both. So on the degree of damage, if it comes to 70 to 75, 80% damage, it comes under A5. So I cannot take a risk of repairing or retrofitting the structure where I may only be able to achieve up to 45 to 50% of the strength, and the structure will still be, there is a question mark if it can be used. That is the purpose I put this to classification and assessments. Yes, no, from the code and based on reports also, this has been put now. No, yes, this is a bit put it for the lecture, how we have been taking it from the inspection point of view. Sir. No, there we have to give this clearly in as a like how we give it in any kind of in the designs also in our design notes. These points are being put, and so your structure comes under this. So this needs to be taken into immediate consideration, and you may have to evacuate. Now coming to visual inspection, when we come to visual inspection, what is that? Which we have is structural serviceability. What are the materials used? Deterioration mechanism which has taken place in the material, general condition of structural and non-structural elements which are existing, preparation of estimates and bill of quantities also which we have to go through. Quantify extent of distress which comes into that, photographic records, obstructions for visual inspections to be noted. If there may be some portions in the building which we may not have access to, which there may be some vaults and other places where we don't have access to, and in such cases we'll have to give this in the report stating that these are the obstructions for the visual inspection which were there. Understanding structural systems and deviations based on the sanction plan with what we have. Apart from that, and also as per the structural design which has been done, any other deviations which has been done, has it been followed as per the structural design which is followed, or if there has been any changes which has been made, that also needs to be taken down. Leakage, seepage due to inadequate drainage systems needs to be noted down if there are any leakages which are there. Types of cracks and its patterns, which I'll be talking about later. Color and texture of concrete surface, that is if it's a chemical attack which has taken place, or if there was a fire in the structure. Basically, there are classifications based on even on Eurocode, which is there, that for various temperatures, the color of the concrete changes. So based on that, I have not included that, but I will, this also can be taken into consideration. Areas of, now in the record, once you have done all this, what is that in the record which you are going to take down? Areas of high distress, cracks and their locations, where they are located, excessive deflections if there are any, exposure conditions of various distressed areas, moisture, seepage, leakages, which I have talked now, abnormal vibrations in the structure, limit state of serviceability, where in case it's been breached, in case if people are walking up or if it's moving and there are vibrations felt, that also needs to be noted down. Algae, fungus growth, trees on the structure. This is one of the most detrimental part in buildings, what we have seen, which leads to crack formations. Photographic record, areas of immediate concern. So coming to this particular work, now I would come to condition assessment. I'll just put it as a flow chart very, very briefly, and then go ahead with the other part of the presentation today. Preliminary investigations, review of relevant documents. I'm just summing up everything with respect to condition assessment here. Review of relevant documents, visual inspection with documentation of defects, field and laboratory testing, preliminary analysis and evaluation. Once you're done with this, you see, is there further investigation required? If yes, what is that which is required? Detailed investigation, review of additional documents and data sources, additional field observation and field and laboratory testing, detailed analysis and evaluation. If it is not required, you go, is repairing required? If you have to check with this. If yes, identify an analysis of the repair system is applied, and analysis is done to check its efficacy and then applied. Because at present, what we are seeing in the particular field is there is repair applied. How effective is the repair? How efficient is the repair? How well is the repair performing? That also needs to be checked, which I'll be talking on the later part of the presentation. If no, identify special conditions to further that is further consider. Example, maintenance and planning, you can suggest to the client and you can close the report. Now, the next mode in condition assessment, how do we do, is one of the tools is non-destructive evaluation and testing. When is this non-destructive evaluation and testing considered? It is considered when it is put under these 5 categories based on purpose. In situ concrete strength, when we have a doubt on the concrete strength which has been developed in the structural member in the site, we go for that. when there is any form of chemical attack which has taken place, or there is chemical spillage which has taken place, which has caused damage in the structure. Corrosion activity in the reinforcement, fire damage, where there is a fire, structural integrity and soundness, because today many of the structures, there are cases where someone purchases a building, they want to check what is the structural integrity and the soundness of it. So they go in for NDT and structural evaluation of them. So in that condition, we go for non-destructive evaluation. Now coming to sources of damage in the structure, this, excuse me, sir, can you please close that window? Expand window. Yeah. So coming to now, we talked about the condition assessment and degree of damage, as well as assessment of the damage which is there, classification too. Now coming to the sources of damage in structures, basically I've taken this from ERI report, from the Bhuj earthquake data. Basically, this is the earthquake damage which has taken place. What we can see here, many of the buildings, this is a soft story effect which has caused this building, one of the floors, the bottom floors to have, the columns to have failed, and the whole thing has come down. And we see the water tank also, that is because of mass irregularity which has taken place in the particular structure when there has been earthquake shaking, and you would see that some portions of the structure has collapsed and major damages have taken place in the structure. Especially this is the case of the Bhuj earthquake, which when it had taken place, these are the photographs of the structures which have been damaged during that earthquake, which are presented here. Now coming to the damage due to corrosion. Now the corrosion can be basically due to water leakage, and also in some cases where the structure is located in saline environments. We come across bridges which are there in across the particular sea environment, and we have also cases where we have a case where the structure has been having water leakage and it has undergone corrosion. Especially, I'll come to a case where we have done earlier for one of the corrosion damage case. I will be talking about that NDT in the next few slides. Fire damage. When there is a fire which takes place, basically the concrete gets damaged much extensively, because up to 200 to 250 degrees, there is not much damage in concrete. But when the temperature comes close to 300 degrees, what happens is the concrete, the free and bound water in the concrete tend to break down. The free water is lost when it goes close to 300, and beyond 300, the bound water breaks down in concrete, and therefore after 300 and upward, the drop in the compressive strength of concrete is exponential. Especially at what, from my experience, what I have tested with concrete at high temperature, I've seen is at for concrete for a temperature of 500 to 550 degrees, the compressive strength comes down close to nearly up to 50%. For a temperature exposure of 500 to 550 for a duration of 2 to 4 hours. 2 to 4 hours as per ISO 834 and as per Eurocode considerations too. So, and the most important thing, what happens in fire damage, there is a loss of bond between the concrete and steel, which is very, very rapid, because the coefficient of thermal expansion of steel is much larger when that compared to concrete, which leads to the loss of bond. Once the loss of bond has taken place, it's going to cause a problem, especially coming to, if I take a column member, if I'm going to take a column member and I have the reinforcement and the core. I have a certain, this is at the column member exposure is such that it is exposed at some temperature T1, T2, and these places it's at T ambient. These faces are at T ambient. Maybe there are walls here. This is the exposure. When this is the condition here, there is something what we call as 500 isotherms, what we come across, where the temperature seepage which takes place inside the particular member, if it's well within the concrete cover, that is fine. But once it reaches towards the core of the particular structural member, it tends to start losing its strength and its repairability also becomes a question mark. When this, what we call as 500 isotherms, it means to say what is this thickness of the particular concrete for which the temperature has seeped in with respect to the external temperature. We have a certain internal temperature, if I call it. If this internal temperature is close to, if it comes less than or comes close to the external temperature, it is a problem as it goes closer to the core. So fire damage is one of the most predominant what we are seeing in today's date. There are many fire accidents which are taking place in the structure, and assessment of that also is a major requirement today. Now coming to damage due to error, it's the same photos which I have considered from ERI for Bhuj earthquake. You can see that in certain cases, the lateral ties have not been provided properly at a certain spacing here as per the IS codal provisions and earthquake codal provisions, IS 1893 earlier version also. Now we have 2016 and 13920 as based on that 2016. Compared to the earlier versions too, the ductile detailing has not changed much. So, but still this has not been followed, though Bhuj is in earthquake zone 4. We have 4 to 5. Here you see that the beam column joints, all of them have just been pulled out. This shows an error in design. The shear wall badly been damaged because of the earthquake, which shouldn't have happened. So this is one of the reasons. Now coming to damage, the sources of damage in masonry also, we have erosion of brick faces which takes place, efflorescence in bricks spalling and delaminating also. In such cases also where we have masonry structures and they are the load bearing walls, and in such cases when the damage takes place, this becomes another issue with the stability of the structure. Now coming to assessment of damage in a structure, the assessment of a damage in a structure can be considered using NDT, non-destructive testing. So in NDT, we have the various techniques which we have is ultrasonic pulse velocity testing, rebound hammer, acoustic emission. Core test is a semi-destructive test by visual inspection and making all the note of how much concrete has cracked and if steel has demortared or steel stirrups or ties have opened up. This also needs to be noted down in severe damage cases. Half cell corrosion is one of the tests which is considered for corrosion. Carbonation test as also in correlation which goes with half cell corrosion meter. Now coming to very quickly, I will run through. I have put. I'll not take much of time with this. This is the ultrasonic pulse test of a particular building which was taken in Bangalore here. I would say I would give my due regards to Dr. K.S. Jayasimha sir, because I have been working with him. So for when I requested him that I would be like to be involved with one of the work. He was magnanimous to get me involved with this. So this was one of the structure where it was an old building where we have done all the non-destructive testing. So this was the ultrasonic test done using Pandit, that is from Prosec. So coming to this, because of various confidentiality reasons, I cannot share the results. I'm just putting across the particular outcomes. So basically the ultrasonic pulse, when we come across, we see that when the pulse velocity is below 3, the concrete quality is doubtful, and when it is above 4.5, it is graded as excellent. So, and between 3 and 4.5, when we have the pulse velocity to vary from 3.5 to 4.5, it is good, and from 3 to 3.5, it's medium. Now, at the present case, we have IS 516, which has been revised at present. Earlier, we used to use IS 13311 part 1 and part 2 for ultrasonic pulse and rebound hammer. But at present, IS 516 has been also revised, which has been taking this into consideration directly. Now, in this case, what we see is that there are cases when we tend to have a lot of cracks or we have voids of the concrete is completely cracked. What happens is the pulse time taken between the pulse time taken between the transmitter and receiver takes a larger time. Because of that, the velocity comes down for the same distance of traverse. So therefore, the pulse velocity test gives us a gives us an idea of what is the quality of concrete which has been present there, more than exactly the strength. But there has been a debate on this to find out the particular strength of the concrete. What is the compressive strength of the concrete by finding the dynamic Young's modulus, and from there finding out what is from E, how we have EC is equal to 5000 root FCK, what we have it at in IS 456-2000. There are cases where it is tend to looked at for concrete from the particular velocity. We can find the dynamic Young's modulus and the strength, but that is debatable. Today's date, that can only be done based on a lot of tests from ultrasonic pulse, the velocity, and what was the grade of concrete which is that was existing. Based on that, a curve can be plotted and it can be got through that only, because when we go for higher strength concretes, the density comparatively, for example, the density between M25 and M45, there will not be much of a difference. So there we cannot really say that the strength would be exactly this based on the ultrasonic pulse. So based on the values what we have got. So it would further tests would be better, like in case if it's really required, semi-direct like core test may be required to go for it. Now coming to the next is rebound hammer is another method to just give us the surface hardness of the particular concrete. Today's date there are we have the digital rebound hammer which we have from Prosec or from different companies which have come across, which give us also the compressive strength which is displayed onto the display what we have, the LCD. But this method is to find out what is the amount of surface hardness which has taken place, and based it's a rough estimate of, not exactly rough, I would say it's another mode of estimate of the the quality of concrete and the strength, which can be correlated based on the rebound number. Based on the rebound number, we have the earlier particular rebound hammers which used to have a particular curve. The curves used to be provided between the rebound hammer number and the compressive strength. So based on that, it was found. That is the surface hardness. Based on that, that is the compressive strength. But what is that which is there at the core? We don't know. So in such cases, we may have to go for core test only if it is required. So the next is the perfometer which was used here. This was a case where there was serious leakage from the toilets which were there, which had damaged most of the reinforcement in around that particular structural members, especially the beams, columns, especially even the slabs. So this helped us get what you can say we can get. Now this is get the particular voltage based on a certain voltage from the corrosion meter, half cell potentiometer, where we use this copper sulfate solution as the anode and the cathode. What we use, we get to know if there is corrosion activity. Is it stagnated or is it still progressing? So based on that, we can also tend to plot the contours and see that what is the degree of corrosion which has taken place, or and also we can, in the report, we can get to also mention that if the corrosion can progress or not also. So the other method is to find out corrosion is concrete resistivity test. Based on the particular resistance which is obtained using this particular instrument, we can tend to get a possible note of corrosion that may be taking place in reinforcing bars. So the other method is phenolphthalein carbonation, which is a carbonation test which goes hand in hand with half cell potentiometer. So basically this same building which we assessed, there was some portion of the building which was in a column which was the concrete was taken off up to the core to just check what is the degree of corrosion, and there were core samples which were also taken here, and this was a place which was exposed to the main road. So it can be seen that more amount of carbonation has taken place in the concrete which is more exposed to the pollution which is there, which is majorly carbon dioxide, carbon monoxide, and all the pollutants what we have, especially the carbon dioxide and carbon monoxide what we have. The other is the core test which we use. The core test is basically, the core test is basically used as a semi-destructive test to find what is the in situ strength of the concrete and to take a sample of the concrete which is present between the reinforcement, and that can be tested in the site to find what is the in situ actual strength of the concrete. It may be you're taking a core. If we have to take a core, it is better if we have the column and we have the reinforcement here. I have not included one particular non-destructive test is the profometer. Using a profometer before going for a core test, we use the profometer to scan, move it up and down to find out where the reinforcements are, mark it, and after that, where the reinforcement is not there, we can go for a core test when there is a doubt in the concrete quality which is required. Never to take a core where there is reinforcement. So I'm sorry, I have not included the profometer, which I'm just telling you. Now the profometer is used basically to find out where the rebar locations are. It gives the approximate estimate of the concrete cover, the approximate diameter, I would not say exact, and the location of the rebar. So based on that, when it is marked on the site, after removal of the plaster, the profometer test is done, and after that the core can be extracted. This is a case where the core has been extracted from the foundation, from a footing. So the other methods are tomography methods, that is CT scanning, which is there. So basically it's a radiographic testing. I have at least witnessed this in UK where they used to use a certain small instrument with complete lead coverings. You know, they used to have an apron which has lead as well as the, but it requires a bit of instrumentation. So we tend to get where the exact location of the flaw is using the radiographic method. This is one of, I have taken this from a source where the concrete has been scanned to find out what is the condition of the reinforcement and where the flaws are. It's a reinforced concrete column which has been scanned using radiographic techniques. Today, this has also been used in our non-destructive testing modalities. So this is one of the examples I can say where building in which has been assessed using radiographic technique to find out, it's a very old structure where it is a combination of both masonry as well as RCC. Lime concrete has also been used where one needs to find out where the flaw and the type of materials which are used need to be found out, including the density. There is one thing I would like to tell you in radiographic technique. There is one method. If you see this, this is an X-ray image, or you can say a CT image. If we take a CT scan of any of our body parts, when we go to the diagnostic center, we get a CT image. Interacting with some of the radiographic people who have been using in the CT scanning sector, in the radiography sector, I have got to know, and there are papers which are available also. There is something called as Hounsfield units, where it tends to give the density of that particular material, especially the bone, which is very, very dense. It is very bright. Similarly, in these conditions where we see the materials here that are very bright, that gives an idea about the amount of denseness of the material. Especially in fire damage cases, what happens, even the coarse aggregate which is there tends to lose its density by developing porosity in the coarse aggregate. And when CT scan images have been taken of the same, it can be seen that it would not be bright. If you put it under a CT machine and you take a CT scan of that, some portions of it look not much brighter. So coming to the next is crack width measurement is using these crack width measuring which are available. And this is important. Why is it important? Because many think it may be okay seeing the crack, but as per the codal requirement also, where the cracks have developed, it is better if we have this, if we have a measure of what is the crack width, that would be good enough. And to further monitor that same structure, has the crack width further opened up or not? This would help in that. Now the next is the endoscopy studies. What in NDT, what we have come across is what we have the endoscopy, what we use for humans having a camera. Now the present studies, what has been seen is the case where we have these steel structures where we have we have box sections or pipe sections, or what we call it as the circular sections. If it has undergone corrosion, we don't know. In such cases, there are some places where we can bore a hole, or in the structure, we want to see if there is a void. We can use this technique to find out in the way what is the type of damage which has taken place there. So today's date, the endoscopy is being done, and I have come across this in I have seen this instrument along with working with Dr. Jaisima sir in his office. I mean to say, when I was working with him with one of that particular work, as part of my curriculum from my institution where I was working earlier at BMS Institute of Technology. So at that point of time, I have seen this instrument, I would say that, and later I digged into it to find out how it can be done. And later I checked with some of my colleagues at UK also. They said this can be made also by any one of us, and it can be connected to the laptop, and it can be put on screen recording, and the whole data of whatever is to be checked or to be studied can be got. The other one I could not put here. Where is this endoscopy studies applied? Concrete pipes, water pipes, storm water pipes, sewer lines, culverts, cavity dams, air duct vents, chimneys, ceiling roofs, and floor voids, water tanks, heritage structures, timber structures, and concrete or masonry structures with large voids or honeycombing where it has taken place. The other part which I would like to tell, one more thing was GPR and thermal imaging, which I had been discussing with Umesh sir, in fact. So that I have left out here, I'm sorry, my due apologies. So basically that can be used, the thermal the thermal imaging can be used to find out if there are water leakages also in a structure, in fact. Now coming to the other method is the load test, which has been applied. That is the sandbags which are usually loaded onto a particular floor to check for deflections. You can see here, it's not, I think it's too small here. I mean to say there's a dial gauge which is fixed to check for any possible deflections in structures, in buildings. In case of a bridge, what we have, this can be monitored using a survey instrument also to check what is, if there are any deflections in the bridge spans what we have. It can be. So these are the particular dial gauges which are used. Today we have the digital ones which are available, and today people are also going for wireless mode of getting the particular data in real data condition, which we have also tried with. I have tried with my students, which I'll come across later. So the load test is as per IS 456-2000 recommends load testing of flexural members to carried out in case the core test results do not satisfy the requirements. Many a times load test is carried out on building and bridge components when the strength of the concrete is below the acceptable norms. Structural design data is not available. Load carrying capacity of the flexural members need to be assessed. The members is to be subjected to higher loads later. If that needs to be later, there is an upgradation which is required for the load carrying capacity. The members are noticed to have cracks and deflections. The structure is damaged due to fire, earthquake, or blast. Change in use of the structure. So in such cases where we observe distress and the core tests are not giving us apart, the core test is usually taken as the last test. It's like usually to a human, what we go to when we go to the hospital, the doctor does all the tests first, and the last would be the surgery. So basically the first NDT test, if we are able to get most of the data and then go, if we are not able to get proper conclusive results from that, then we go for the core test. Any client would not be very comfortable to get the plaster removed and get the core done. This is my experience, what I have seen. So in such cases, when the core test is not so conclusive, we go for the load test. Coming to the type of cracks. Now coming to identification of damage. Basically, we have the types of cracks. We have a airline crack, which is, now we talked about damage. Now we are going towards it, identifying that, and then going into design of repair. In fact, airline cracks, minor surface level cracks caused by a variety of reasons. Shrinkage, cracks on surface, that is cracks caused due to shrinkage of concrete because of heating and cooling of, especially we come across on our terraces and our exterior walls too. And settlement cracks, whenever there is a foundation settlement, we see there this kind of cracks which tend to take place in structural concrete members as well as in masonry members. This is where the structural crack is, this is pretty serious when there is a problem with the load carrying capacity as well as when the damage is a little severe. In case if there was some kind of an earthquake or there was heavy settlements which have taken place which causes these kind of cracks. Now, cracks in a structure, we just saw what is the type of cracks. How do we identify the different type of cracks in a structure? I've just presented one portion which have especially from with respect to columns. Cracks due to eccentricity in eccentric loading conditions. Cracks due to corrosion, especially when there is a loss of bond between the concrete and steel. This is the cracks which are usually parallel to the reinforcement. Cracks due to increased column load. This is basically there will be a bulging or there is going to be a shear failure. I will just put that across here. Here you see the concretes, you get this kind of diagonal cracks also, and we get this type of cracks which cause bulging also. It causes bulging also due to loading. And in case of beams, horizontal members, what we have, the cracks will be basically flexural and shear cracks, which tend to propagate with loading or the condition for which it has been damaged for. Especially in masonry, we come across it is not so clearly seen here, but we have the different types of cracks which take place in masonry here. If you see that this is basically the cracks which are taken place at the joints, and some places of the cracks which have taken place, which is shown here, it also signifies settlement also. And coming, well, this is a repetition of the same what I said. This is the splitting cracks, especially when the concrete is bulging because of overloading which takes place, or there is a deficiency of the load carrying capacity when the concrete is loaded or the concrete column is loaded. How are these cracks repaired? The stitching method, yes. Exactly. Now the crack is progressive or not. One mode, that's what I'm sorry. One mode which I just talked about here was we are monitoring the cracks if possible, if we have this particular type of an instrument, or there is another method, at least what I have come across in the site is have a reference point of few markings with respect to a certain markings. And if the crack has widened, or it might have propagated. The crack tip is here. If this is the, sorry, if this is the crack tip, I have a particular, for example, I have a beam here. I have a beam here. I'll just take a case of a simply supported beam. In this case, I'm just giving you an example of this. I have a crack here. This is the crack, sir. This is having a certain crack length A, and it has a certain crack mouth opening displacement W. Now, if the crack has to propagate, if there is a reinforcement here, I'm just giving you an example. The reinforcement acts as a closing force on the crack usually. So if this crack has to propagate, it propagates here. In such case, how do you have a reference? So in this case, with this propagation, we would have marked it here. You can have some markings where it's in actual structure, you will not have it like this. I have it like this. It would be something like that. It's a mixed mode crack. This is a mode 1 crack, what it's trying to open up. It will be inclined. So what we do is we'll have some markings which is being done with respect to a certain points. And if this crack has further propagated, it means to say that if there is a crack which you see beyond those points, it means to say that there has been an extension. You think you don't have this. You don't have, not all of us may be having the liberty to have access to this in the site at that moment of time. So what, as an engineer, as a structural engineer, what we can do at the site is marking. Yes, sir. Yes, sir. Retract. 1/r. Yes.
Sir, we are not able to hear. Hello, sir. We are not able to hear.
So did I answer your question? So with respect to this, coming to the different type of cracks and its identification, how do we repair these cracks? By the stitching method. The stitching method, especially, it has also been mentioned in IS 4326 also, at even for masonry. And the one is a stitching method where you use a U type of a bar where you have drilled in holes there, and you take a certain bar of a certain diameter, basically an 8 mm bar today what is available, and it can be put across, it is put in so that this particular rod here will be acting as, it will be taking the tensile load. If this crack is trying to widen, there is going to be a closing force onto the particular crack because of the rods. The other one is cement grouting, drilling in plugs. Then the other one is epoxy injection. So these are some of the methods of repairing the cracks. The other one is, this is what I told you, is the stitching method where you drill holes. That's what I told. Fill the holes with non-shrink grout or epoxy and fill it so that these rods don't, so that these rods don't get pulled out. Basically, the chemical anchor which is available today, the chemical anchor from different companies like Fosroc or Sika or BASF, we can use that. And also the other method is, if for example we have a crack in the beam here, today we are using this external tension tie as a pre-stressing modality to see to it that the crack does not further open up and propagate, because that load is taken by this particular pre-stressed strand in fact. Now the other method of crack repair, I've taken this from the net. I would be from this particular source. Crack repair for epoxy is, when this can be done, is this method can only be used when poured concrete, not using concrete blocks. If concrete blocks is being adopted for the construction of that particular type of a wall, then we may not have to, we will not be in a position to use this, because there will be joints and we do not know what would be the condition of the particular masonry joints when we are going to pour this epoxy, because our main objective is to seal such kind of a crack, maybe in a retaining wall. So in such cases, we have a backfill there, and if we are also having a water table at a shallow level, you may have water seeping into the basements, especially what we have seen. In such condition, if that is a RCC wall, predominantly it is in most cases, we can go for this epoxy type of and polyurethane injection, which we use. So coming to the assessment of damage in a structure, we go for the repair techniques. Before going to the repair techniques, we need to understand what is the difference between repair and retrofit. Coming to a very basic understanding of it. I have not coined any definition, but it's based on a understanding. Repair or rehabilitation is a strategy used to strengthen a damaged or aged structure close to its original strength, or the member, whatever is there, original strength, by utilizing repair techniques available. Eventually, the stability is also taken care. Retrofit is a strategy used not only to strengthen a structure to its original load carrying capacity, but to also enhance its load carrying capacity or strength beyond its original strength. When is this done? Well, let me give you a very simple example. There has been a structure whose foundation has been designed for 5 floors, and the structure has been built for 3 floors. The basement columns have not been designed for 5 floors, but only for 3 floors. In such a case, another 2 more floors, the owner or the successive owner who buys the property or who is existing decides to put 2 more floors later. Maybe for various reasons, the basement columns were designed only for 3 floors. It may be, I have seen conditions where they say because of cost constraint and various things. So in such case, if we have to put 2 more floors there, we have to go for a retrofit technique, not a repair, where we are strengthening the load carrying capacity of the existing basement columns, which are not having any form of distress or damage, but we are retrofitting it so that it carries the axial loads or moments which come onto it due to another 2 floors. So this is a picture of what is repair and retrofit. But when we cannot do it, repair and retrofit of structural components is done only when the damage is within repairable limits. as we talked about degree of damage. That's why I started from degree of damage and assessment, and I came along with that so that you are able to get a complete picture of it as a holistic part. If the damage is beyond a certain degree, it's of no use. It's like trying to revive a person who's just going to die into and trying their best to put the best efforts in the medical sector to revive. I'm sorry to say this, but for a structure which has 75% or 80% of damage in a structural member, you cannot go for a retrofit. It's not going to be feasible. Now coming to the materials which are used, very quickly running through it: epoxy to seal cracks, FRP sheets, carbon fiber reinforced polymers, glass fiber reinforced polymers, GFRP, armored fiber reinforced polymers that are glued to the concrete surface using high strength epoxies. And there are also today the strips which are available, CFRP strips, GFRP strips which are available, where the particular fibers in a fabric form is embedded in the matrix of the epoxy, and that is being used as strips directly, which can be applied, and in some cases that is used for pre-tensioning also, as pre-tensioned epoxy strips. Steel plates are also used. Concrete or cement mortar with epoxy to do patchwork, epoxy to bond old and new concrete. I'll be talking about this. We have done a case study of this. Epoxy to fix new rebars in existing concrete to create a link. Now, damage and type of repair. Till now we discussed about the different degrees and assessment of damage, or classifying the damage based on, it's like your degree of the damage rank what we have. Here, for example, damage rank 3 or less, where the cracks are in this form, sketch of the damage what we have. So the repair of cracks, repair method, repair of crack and partial loss of concrete. In such cases, what is the type of repair method which we go for? We go for especially patch repairs. It's not been put here. I've just put patch repairs. In rank 4 type, what we have, when the cracks are there and the reinforcement is seen. The cracks are there, the concrete has spoiled and the reinforcement is seen. You go for basically grouting mortar with pressure to repair this, jacketing with welded wire fabrics and mortar, jacketing with steel plate grouting mortars. The next is rank 5 is when the cracks are there, the reinforcement is also visible, and if the reinforcement has shown some form of distress in the form of it has bulged. In case you go for jacketing with steel plate grouting mortar, jacketing with steel plate, addition of vertical reinforcement grouting mortar also in such cases. And one more thing I would like to add here, it's not been mentioned here, is use of CFRP wraps and GFRP wraps. In such cases, we go for that kind of a repair when we are wanting to have an enhancement in the strength of concrete, maybe around 10 to 15% more. We cannot go for RC jacketing in cases where CFRP wrapping, where the damage is much beyond a certain 15 to 20% beyond the particular requirement which is there. Yeah, CFRP, that's what I said. So carbon fiber laminates, carbon fiber wrapping, that is fabric wrapping with epoxy, or glass fiber laminates or glass fiber wrapping fabrics with the epoxy can be done when you need a increase in strength up to 15 to 20%, not beyond that. Because if we are going to put it like a bandage, like more number of wraps, it is going to become ineffective. And secondly, the aspect ratio needs to be taken into consideration. What is that?
Sir, we are not able to hear. Please hand over the mic to Umesh Birao, sir.
Yes.
Hello? Hello?
Hello, we don't know what's being talked. Hello?
Yes. Yes.
We're missing the whole thing.
Carbon fiber.
Hello, can something be done?
We are not able to hear you.
So, if I take the stress strain curve of carbon fiber and glass fiber reinforced, that is CFRP, carbon fiber reinforced polymers. In this case, if I take 0-90 orientation of the fibers, sir, I have the 0 degrees, I have the fibers and 90 degrees. I have a fabric which has been oriented in this way, and I have a load which is acting on this in this way. Basically, these fibers they take the particular tensile load, whereas these fibers have a Poisson's effect, because of which they tend to have a compression. But there, when you come across with the elastic modulus, as sir mentioned, it has a very high E, but at the same time the stiffness goes up. From my testing, what I have checked at when I had done it at Indian Institute of Science, when I had wrapped the carbon fibers and glass fibers, there's a sudden brittle failure with comparative with the CFRP when compared to GFRP. Yes, GFRP to GFRP, but from when there is a strength requirement, sir. When a strength enhancement requirement is there, we go for CFRP. Yes. Yes, the ductility. Yes. So with respect to this, coming to the aspect ratio, what I just said is, if I have a column here, I'll be talking about that. If this is B and this is D, the aspect ratio of D by B for carbon fiber or glass fiber FRP laminates, which is to be wrapped, it should be preferably less than at least or equal to 2. If it's beyond that, the repair becomes ineffective. I mean to say, it can delaminate. And once the carbon fiber or glass fiber repair, FRP repair, delaminates, the repair becomes ineffective. So, yes. No, this is, I mean to say, that's what I'm saying, jacketing with steel plate, grouting mortar. We use this micro concreting is using gunneting, which is done, which is, I wanted to mention that in the forthcoming, I will show you the next slide, sir. You see this reinforcement. This is what I wanted to say. You see this reinforcement, the column reinforcement, especially longitudinal rebars are bulged. This is a case for, in both cases, this is a case where CFRP wrapping has been done. And in this case, we have RC jacketing which has been done. So in both cases, you see that what has been done basically is extra, it has to be seen to it that as much as possible without disturbing what is there, it is restored, and we have some portion of micro concreting is done and the wrap is done based on what is the confinement which is required there. Whereas here, when the load is very high, and we would see that the lateral tie spacing, here we would see the lateral tie spacing, there is not much of a problem here. Here the lateral tie spacing is feeble. In such cases, we go for this RC jacketing where the load carrying capacity or the strength enhancement is beyond 15-20%. We go for RC jacketing, and we take this for our FRP or FRP wrapping, in fact. This is a case of retrofit. I've taken from the net. I would like to put it across. This is basically for an understanding purpose which has been put to all. So basically, this is the column retrofit which has been done. If you would see here, that is the RC jacketing of a column, beam column joint, and that of for a beam which has been done. In such cases, and this is a case what I wanted to talk about, there is a column which is badly damaged and immediately it has to be restored. In such cases, I sections have been provided around it like props, because props would not be in a position to take up that load, because this whole portion, if this settles down, then it can, this column can punch through that if there is a beam there. This is a case of a flat slab I will just come across, or you want to restore that portion. This has gone around where they have provided the reinforcement and welded it like lateral ties to hold it and give the confinement to the concrete as well as take the vertical load. Now this is a case of a flat slab repair where RC jacketing is done, and even the steel plates are used at the column drop panel interface to take into consideration for to make good of the particular deficiency of the flat slab which is there. And I just wanted to, I just wanted to tell you, I'm talking about this, I'll be very shortly talking about this shear keys which have been used here for the RC jacketing. These are one of the most important part when we are going for RC jacketing to bring bond between the old and new concrete, which we have done an analysis on this with along with Jayasimha sir, which I want to put it across. This plays a major role. In many cases, I have seen in the retrofit that this is not properly designed. The spacing of the shear keys is not taken into consideration. There is just one or two, a few of them. Okay, it will hold the concrete. It's not so. The bond stress or the interfacial shear stress which develops between the concrete, new RC jacket concrete, as well as the old concrete substrate will lead to slip and eventually make the retrofit inefficient, in fact. So coming to this is a typical case of carbon fiber repair of these basement beams to enhance the strength. This is the CFRP strips, as sir suggested, CFRP strips which have been used to repair the slabs and the flat slab drop panels. This is a case of the concrete cover which has been taken off for the slab, and the entire slab has been retrofitted using CFRP strips. So this is a case of a footing repair. This is a case of a footing repair where RC footings have been retrofitted, where we tend to, for example, what we do in footing is, if I can rub out this, we have the footing. Take the case of a footing which we have, and this is the bed concrete if we have that. Now, this is we have to enlarge the portion of the pit by giving supports. What is done here is increase the area. How do we increase the area? It is in plan also. This is in plan. What we tend to do, we increase, what we say is the section enlargement method or the RC jacket method, where the reinforcement which is already existing, this is the existing reinforcement of the concrete footing. We tend to chip off the particular cover, and existing rebars which is exposed, it can be welded and it can be brought on top. Extra rebars which can be embedded using concrete chemical anchors are placed, and this is extended. At the same time, reinforcement is placed on top also to embed it in such a manner that this area of the footing is increased such that it increases its load carrying capacity. In certain cases, what it's done is provide a strip beam also by just taking off some portion of the particular concrete and provide a strip beam so that the particular behavior of the footing in a particular direction tends to get enhanced from that point of view. So that this is a case of foundation repair, which is the toughest, I could say that, because we can easily repair beams, slabs of columns or retaining walls. But footing repair is the most difficult case because we have to do calculated yes, we have to take a risk, and calculated risks, and the calculation should be as clear as possible so that it will cause distress later. Because nothing can be done if something goes wrong at the foundation level. If it's going to cause any settlement, and that's going to be another problem to the entire structure. This is a case of steel plates which have been provided like battens. That is in the edges of the columns. Have the column here. So this kind of angles are provided at the edges, and steel plates are welded to it like battens along the length of the columns. This is basically to enhance the confinement and to increase the load carrying capacity of these columns. This is a classic case of RC jacketing of the columns and inclusion of new plinth beams which have been provided in the structure. In some cases where there has been cases of deficiency from that point, another way is inclusion of new shear walls into the structure. we have the particular columns here. It's basically the ones, these are the shear walls, which we call it, we design it without end elements and with end elements. So this is the columns act as like with end elements, and especially this would be most helpful in the case of earthquake resistance in earthquake zones. This would be helpful, especially we have the shear walls which are like this. We have the column here, and this we call it as a flange, and this is the web of the shear wall. So basically these are the existing columns. This reinforcement is taken in, it is embedded using chemical anchors. It would be better because of, in some cases, if the concrete is 40 mm or more, we are trying to take it off, tends to damage also the columns in certain cases. Some places it is welded, and some places it can be embedded, where we are not able to locate the particular the reinforcement in the columns. So this is the inclusion of shear walls which is there from the point of increasing the stiffness of the building in earthquake prone zones. Inclusion of shear walls which are provided in a symmetric manner in the structure in the plan tends to increase the in-plane shear resistance of the building, as well as it tends to increase the stiffness of the building, thereby reducing the lateral drifts and the story displacements. Now, coming to the different types of failures in FRP repair, what we come across in, which we have to know is, one is FRP rupture, intermediate end debonding, and what we call it as intermediate debonding. The most important thing in FRP repair, what we take into consideration is we have to see to it that the epoxy is well adhered to the FRP fabric, or the FRP sheet, such that there is no delamination which takes place. Once the delamination has taken place, that becomes the end of that repair, because it becomes ineffective, because in case there is going to be an intermediate debonding, there is only contact between the substrate material and the FRP sheet here, whereas it has debonded in the flexure zone. In such cases, it will lead to sudden failure, leading it to fail. So this is one of the testings which has been done by Dr. Jeff Chen and Teng. It was Dr. under Jeff Chen whom I worked at University of Edinburgh. He used to work on FRP composites, especially on repair of structural members which were damaged due to mechanical loading as well as on fire. So these are the cases where U-strips were being used, like external stirrups, what we call it as. It is being provided such that based on the shear resistance of the FRP strip and the concrete substrate, based on the type of particular epoxy which is used. So I would say that makes a main difference. I would like to make use of the name of the company, Atul Industries. They supply these epoxies, which I have made use of for adhering the FRP fabrics while I was doing the testing. It was what was my observation is that a chunk of concrete used to come out along with the FRP. So that would be the strength of the type of epoxy which is used. I would find a few coarse aggregates and one chunk of concrete would come out. But that is the most important thing. The type of strength of epoxy which is used is of most important. This is a case of strengthening of existing masonry wall. I'm coming towards the end of the presentation. I will not be taking much time. This is a case where the masonry wall needs to be retrofitted or strengthened. One is providing a reinforced concrete. Is by just providing, using chemical anchors at one end from wherever it starts with. What we call it in earthquake resistance of masonry. If we have the masonry wall, we tend to provide, if we have a masonry wall and we have for example, this is a door.
Reddy sir,
and
please
this is a
mute. Reddy
window.
sir, please mute.
Usually we have a roof band, what we call it as a roof band of the beam, and we have the lintel band. Definitely there will be another band which people provide even at it's there as per the IS code, fill band 2, and these are all the reinforced elements. So what is done to the masonry, what is left is we provide vertical reinforcements in between, that tends to give the ductility to the walls. Because during an earthquake, the major killer is the wall. Because you have the concrete beam and the RC beam and the column. If you are given the proper detailing of the reinforcement as per IS 1893 13920 IS 13920 2016 ductile detailing, if you have provided proper anchorage and you have provided the reinforcements which are at a close distance at the joint, and inside the joint
Mr.
also
Reddy?
there is a certain
Mr. Reddy, can
reinforcement
you
lines which
mute?
are provided. The joint is confined. But what happens? How
Mr.
well is
Reddy,
your
please
wall
mute.
confined with your reinforced elements? Because most of the places what I come across, I see is that the frame has been designed for earthquake resistance. The building is safe. But there are places where the entire wall has fallen because we have the unit weight of wall is 19 kilonewton per meter cube. And we have concretes to be 24 kilonewton per meter cube, 2400 kg per meter cube and 900 kg per meter cube. Yes, 600 difference is there, but it makes a lot of difference if a main wall is going to collapse. Forget that, a foundation wall itself collapses. So from that point of view, we have to go in for this kind of a repair is providing an RC mesh and providing a thin layer of concrete. So we can use 6 mm rods. Today we don't get 6 mm rods. If not, we get the 8 mm rods which are available at a 150 mm spacing. If we are going to provide a mesh, it is going to reinforce the walls. Especially can be used for older buildings. What I have seen is older buildings which are there in Bangalore also, they have this 1.5 thick walls which are made of lime mortar walls. And such buildings can be restored. What I've been seeing is that assessment of such buildings, should they exist or not. I feel those buildings are much stronger and they are existing much better than the present new buildings. So coming to design of repair very quickly, when do we go? We have to design the repair, what we are going to do. We have to design the repair or retrofit. That is a condition. Why we should do it? For example, there is a person who falls down and there is a crack which has taken place in the bone, what we call it as a fracture. So what the doctor does, if few of us, when we have had a fracture in our younger days, there is a plaster which used to be put, and the plaster used to be tied only at the portion where there used to be a crack. But the other portions you could see we could move. Why? What is the reason? There is a specific zone and amount of repair that needs to be provided where the distress is there. For example, if I'm going to provide too much of confinement, I'm going to put too much of pressure on that particular place. Apart from the existing damage, it's going to create more damage. For example, let me say that in our reinforced concrete design, we have something called as an under-reinforced condition and an over-reinforced condition. An under-reinforced condition is when the steel yields and the concrete above the neutral axis crushes when it is under tension, when it is sagging, if I take, or under above or below the neutral axis, wherever the steel and concrete is, steel yields first and then the concrete. Steel yields due to tension and concrete crushes due to compression after the steel yields. So there is some time, there is some warning which is given. Over-reinforced condition is more of a second. The concrete crushes before the steel yields. So in such condition, if we are going to design the repair, we are going to fill up with too much of material, or we are going to over strengthen the structure, it is also not looking good. It can become a case where if it's a static place, like you take, if it's just for a small repair, it's okay. But if it's in a seismically active zone, you are going to strengthen one part of the structure, you are going to stiffen one part of the structure more. The other part of the structure is you will have to make that calculation and check. We have softwares today like ETABS, which is very well versed. You can check about the drifts, you can check about the center of mass, center of stiffness, you can get the outputs from that, you can check it. You have Midas, where you can get it. You have those tools. We have those tools today. Maybe 20 years back, it was a little for us to do the hand calculation and check what is the center of mass, center of stiffness. In such cases, if I just madly provide shear walls all around and some portion have not, it has strengthened one portion of the structure and stiffened it, whereas the other portion is not comparatively strong to that. I would not say weak. When there is an earthquake, it's an imbalance. Similarly for a retrofit, and we also have to look at the cost prerogative. I'm just going to fill it up, the beam is safe. No. How we are going to design as structural designers in our design offices, we have to see to it that a proper design of the repair should be done taking into the consideration of the structural requirements, safety, serviceability, and the last part is the optimization too of the materials is the most important thing. So coming to this, sorry, when do we go for design of repair? Insufficient material strength developed, compressive strength of the concrete. Basically, it's RCC, it's the compressive strength of the concrete is not sufficient, you go in for repair. Especially due to under design, there is deficiency in the size of the sections and deficient reinforcement provided in the members, which you get to know later, okay, this has to be done. And also in the case of retrofit, due to damage taken place in the structure at material level and at the structure level, because we have something called as local damage and global damage levels. So in that case, we go in for that. Here structure level here refers to lack of verticalness in the columns, causing secondary eccentricities, as well as a condition where you have not provided shear walls which are not in symmetry in plan. Settlement of the structure due to poor ground and soil conditions. Now, very quickly coming to the design, as for RC jacketing, if you want to do a seismic repair, we have a code which is IS 15988-2013, where we can go in for retrofit of using RC jacketing for seismic retrofit. But basically, if we see our IS 1893-2016 and 13920-2016, 13920-2016 ductile detailing gives you basically your sizing of your members is done very easily. Your width of your column should not be less than 300 mm, whereas that of your beams also. So D by B for beams also there is restrictions which are being given. So easily you can design. Whereas what we do in our medieval reinforced concrete design is if we have to fix the depth of the beam, we go to span to effective depth ratios and we tend to fix it. But with respect to this, having this as one of the reference, I'm saying, having the code as a reference only, you can definitely go in for design of the retrofit. But what does IS 159-2013 says? The thickness of this RC jacket should not be less than 100 mm. It should not be less than 100 mm, and the details of this particular retrofit, how to go about, it's given in IS 15988-2013. The next is design of repair for FRP. FRP, we don't have a well-designed code for our Indian IS, in our IS codal provisions, we don't have a specific code which is well defined for that. For that, we have, according to ACI 440, which has been revised also now, we have the FRP plate bonding repair. So basically, this repair depends upon the amount of confining pressure which is developed and the amount of how much amount of confining pressure and the strain in the particular material which develops, the strain in the particular fibers, and what is the concrete strength which is required. What is the concrete strength which is required? For example, what we call it as confining pressure is what is the concrete strength which is required. It comes close to it. For example, we have designed a concrete for M25 grade, and the strength what we get from in situ after doing core test is around M21, M22. We have to get it close to M25. In such cases, we go for this FRP wrapping. In such case, what is the confining pressure which you are going to apply such that if you are going to apply this, I have a circular column here, I am going to apply, you are going to confine this concrete using this FRP wrap. So that what is the strength which develops at the core that carries the particular load. Based on the concrete strength, you are enhancing the confining pressure to increase the load carrying capacity, to put it in simple terms. So that, how do you check that? You check that based on what is the strain which is developed also in the unconfined concrete, strains and stresses which needs to be checked. Because if it's going to be an over repair condition, let me also please put this across. If you are going to have an over repair condition, please look here, this is the confining pressure. What is going to happen? It's going to put too much of pressure on the concrete, which is also going to lead to secondary distress conditions. So please, this has to be taken into consideration. Now, if you have a rectangular column, how are you going to do the wrapping? Especially the corners which are sharp needs to be rounded off such that the stress concentration effect is not there and the debonding should not take place. If the debonding takes place here, that's the end of the story. The FRP wrap will simply lie like an external jacket, that's all. It will not have any effect. And secondly, this aspect ratio is most important, H by B. If it is greater than 2, if it's a very large column, then it's like taking the wrap all around and coming. There is higher possibility of error as per Weibul's theory. That is, if we are going to have a chain of links, if we have very less number of links for a chain, there is lesser probability for what you say, a faulty joint misalignment. But if we have more number of joints as per Weibul theory, where there is possibility of higher error, it can snap off anywhere. That's what happens in this. In case of we come across in our architectural plans also, we get very large columns. I mean to say we get columns like this. It looks more like a shear wall. It will be like this. It will be like this. This would be having a certain B and this D, I can say it looks, D is very, very, very large when compared to B. So in such conditions, not only that, you'll also get cases where I have seen plans where we get this kind of columns. It is curved, it has curvature. In such cases, we'll have to think very carefully when we go for this kind of repair, or else it will just be like patching and sticking it. So this is with respect to the most important thing when we go for RC jacketing. I'm coming to my case study here after this, is applying of the epoxy that bonds the old and new concrete. What is done in site, I have observed. Usually what is done, the reinforcing cage is erected first. Then after that, before that, the shear keys are first drilled in and they erect this RC cage. And later what is done, this kind of the, the epoxy is bonded in between the gaps. What causes it? At one point of time, it would not be applied properly for that particular thickness. As per the norms, the particular epoxy should come to tacky condition and only then the concrete should be poured. But what happens in many places, it is just left, it's not there at all. So in such cases, that's what I want to reiterate. That is what we did a study with along with K.S. Jayasema sir, we did this study to see what would be the particular condition when we do the repair, because this forms an important aspect in our retrofit for RC jacketing. So Nitobond EP is what we use in stock chemicals for especially for this bonding epoxy. Please note one thing when I go to this, here it says that the particular bond strength, here, it says that it's 11 Newton per mm square as per ASTM C881. But it's inside, it's usually 11 is never achieved. It is, if we get 5, it is something great. I'll be very straight and honest. We don't get this because of our various conditions of the weather, workmanship, and the application, everything which comes into picture. So this was a case study which was taken of a particular building, which was model column sizes were the basement of a building, 0.5 meter by 0.5 meter. Beams which were considered. This was modeled. This is a FE model which was modeled in ETABS. This work we have published it in one of our paper has been published with respect to this assessment of safety of a retrofitted damaged reinforced column based on bond stress and stress transfer at the interface of reinforced concrete jacket and the old concrete. So with respect to this particular building which was considered, we modeled this in ETABS, put all the loading, run the analysis. Then one particular part of the portion, one column which was considered for the retrofit was taken for study with all the loading, the axial load and the moments which were considered, the biaxial moments. This is the FE model. This is the shear key which has been modeled separately. The reinforced concrete column, this is the inner reinforced concrete column which has been modeled. This is and these are the shear keys which have been embedded. Actual modeling what is being done using finite element modeling in Abacus. So this is the reinforcement exterior mesh of the RC jacket. This is the shear keys, how they are bonded, how they are hooked with the reinforcement of the RC jacket. This is along with the column inside, we have the RC column with the RC jacket. It's the same thing. Now coming to this analysis was carried out to check what is this interfacial stress which develops at the concrete surface. That should be same at the jacket also, or else it will slip. So if we see that, we see it here to be around 0.85. Actually, if we see what sir predicted, it should come along close to around 1. That's it, 1 to 2. So if we see here, it is 8.5 into 10 to the power of 5. It is Newton per meter square. Sorry, all this. So it is converted. This is the RC jacket. This is in the solid form, the solid elements which are being used for the concrete, and the particular reinforcement has been embedded inside this. This is what which has been shown. You can see the shear stress which is developed on the interior surface of the RC jacket. A cut is taken here. A cut is taken here. You can see the shear stresses which are developed to see what is the value which is got. So this was considered for design actually. So sir said, why don't you just do this analysis to cross-check the design. So when we did this, this is the stress in the reinforcement, the maximum principal stresses in the reinforcement which is there. None of them cross the yield stress. None of them cross the yield stress. What we were worried of, what would be the yield stress in the, what would be the stress in the shear keys? Because if they get pulled out, if they yield, that becomes the end of the repair. Even at one zone somewhere, it will cause the distress. So with respect to this is the Tresca, that is a shear consideration. We considered as per the failure theories, Tresca's shear failure theory as per Tresca's stress theory. Here you see that the stress in the particular reinforcement has not crossed the yield stress. This is the maximum, 221 Newton per mm square. It's 2.21 into 10 into 100 into 10 to the power of 6. So we do see that from this work, the stress in the particular shear piece has not exceeded, and what value we considered for the bond stress, we had modeled the particular interface. Let me inform everyone, we had modeled this interface between the RC column and the RC jacket, and the particular shear stress what we considered, we had not considered 11 Newton per mm square, but much lesser. And this, from that we arrived back at the calculations to check if it is safe, and it has come out to be safe. So considering this particular work, this was a case study. Another case study I would like to put is working with my students is with sustainable RC jackets. Sustainable RC jackets is, we have damaged this beam, which is around 2 to 2.5 meters long in the laboratory. We damaged it. We had a control beam where we had the load carrying capacity of that. We damaged it up to 60% of it, released the load, and we jacketed it with sustainable RC jacket. What is that? Concrete made up of GGBS and fly ash, and the reinforcing steel which was used for this was basically this steel from demolition sites, and which was in intact condition. How did we get to know it's in intact condition? We took a few samples of it, many random sampling, tested it in the particular lab, and some of them were of 415 only. We considered all of them of 415 Newton per mm square, which we don't get today in the market today. It's 500 or 550 only which we get. So we put that for the stirrups and this, and we put the strain gauges. I have put the electrical strain gauges which was embedded later in concrete. Tested this to check what is its load carrying capacity. I would like to, and this is where we went and bought this demolition steel. And from this RC jacketed retrofitted RC beam, from this I would like to put it across. The control beam failed at 100. There was a flexure deficiency which was purposely created when we did the testing, when we were casting the members. We reduced the steel which when compared to the control members, like an error in design if we take that. And shear deficiency also with respect to the stirrups. What we reduce the number of stirrups and have larger spacing to have a shear deficiency. And when we tested it with the RC jacket having a thickness of 100 mm only, we could not go beyond that because of the reason of the heaviness in lifting. It had come to nearly 600 to 625 kgs each beam. So with respect to this, we did see there was a phenomenal increase in the load carrying capacity. See, especially of one of the flexure deficient beam, which was retrofitted, with 100 mm, exceeded the control capacity, which was basically beyond 50% of its strength. And for shear deficiency also, it exceeded the control capacity, and much beyond its actual failure when there was shear deficiency. They showed that even sustainable materials today can be used for RC jacketing. I'll be very honest, today people are still having a feeling of fear if we have to use composite cements or if I have to use GGBS or fly ash in our replacement to cement. But with demolition steel, we did get this and we did a cost analysis. This slightly a little older cost I want to tell you, but this can always be multiplied with a factor with today's state rate and increase to get it, but we'll get the ratio. How much is the cost we can save? With this cost of RC jacket using conventional materials for flexure deficient beams, for the beam which we used was around 2 meters to 2.2 meters was 2,191. Whereas the one which we use, the eco-friendly one with sustainable materials, we got it with 1,438 rupees. Where you can see 2,346, 2,300, I'm sorry, and 1,400, nearly 900 rupees we save. So with one beam of 2 meter span, if that can be extended for further, the estimates can be extended, we can see what amount of material and the cost we can save up. The same thing for shear deficient with conventional jackets. Conventional means using 100% cement. Birla Super 53 grade. And this was 2,346, it was same. This came to 1,500 rupees. So from this, I would like to, I'm coming to the end of this work now. We have also with my students tried with IoT. Today's date, Internet of Things has been taken into consideration for structural health monitoring from an NDT point of view, where we have made use of this Arduino circuits to find out how to sense the temperature in a particular structure in case we have embedded sensors. We have made use of K-type thermocouples here. Today's date, we get thermocouples embedded to see what is the temperature which is developed across the cross section, not only at the surface across. It was being placed, the thermocouples were inserted at different points. One, maybe at the core, two, and checked in a wireless manner, such that we use cloud computing, IoT based, where we get real-time data on our mobile. I'm sitting somewhere else and I want to get it. We use this mode of this methodology to find out what is the type of data we get. And we have also sensed what is the displacements in a structure we can get using the same method. This was a low cost sensors which we have used because for the project that we are into for actual structure. I mean to say, this is real life application only. I mean to say the sensitivity, based on the sensitivity of the sensors, which can be still enhanced with the type of interface what we use, because we have used the cloud based computing cloud based interface for getting our data. So this for temperature as well as getting the displacements. This we had our shake table. We had a steel frame. We had mounted these accelerometers at various floor levels for a scaled model, and we checked that so that if we are able to get the displacement. And we also did a FE model of that. I have not presented here because that's on to publication in a paper. So I would like to share that once I get it. I will share it to all of you to check what would be the actual displacements in the model and FE model in this, and do a what you call as a parametric study. So this is the real-time data which we got it on our mobile. Accelerations, what is the accelerations we have got? You can get it on the mobile, and the temperature also. These were the beams which were used where these were heated, and I'm sorry, I don't know if all of you can see, the thermocouples were inserted in that earlier itself. I would end my presentation here. I'm sorry I've taken some time. Thank you. Thank you, sir.
Thank you very much, sir. Actually, we have to give a plot for Guru Prasad, sir, because we openly announced and offered for all the INSTRUCT members, whoever can come forward to give lectures. He is the one person who has offered through mail that I will give a lecture. But today, I want to see, but no silence mode. All the honorable members were listening so carefully. Even a small pin of silence was there. Really very good, sir. And actually in my office, about 1 week back, I would like to say for ME student, I was telling, ಈ ಒಂದು ಕಾಲಮ್ 50 ಟನ್ ಲೋಡ್ ತಗೊಂತಾ ಇದ್ರೆ ಅದನ್ನ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಬೋದು ಅಂತ. ಅವರು ME ಸ್ಟೂಡೆಂಟ್ ಆಗಿದ್ರು ಅವ್ರು ಹೇಳ್ತಾ ಇದ್ರು, ಹಂಗೆಲ್ಲ ಮಾಡ್ತಾರೆ ಸರ್, ಮಾಡ್ಬೋದಾ? People are, so even they are post-graduate students, they are not aware of these kind of things. And she was asking, sir, is it so? Will they do like that? That was the reaction. And I really thank you, sir, on behalf of INSTRUCT. And I offer any questions are there, and the members in the online and offline, they can post about 5 minutes, because already he has taken a wonderful time, because we are lucky to have you as a member of INSTRUCT. And also this gives the inspiration for all the members. So that whoever is there who have got the affection to their own subjects, they can come forward and give the lecture in the INSTRUCT. So the INSTRUCT will grow with you only. You are the people who can lead the INSTRUCT to a greater heights. So I request to take questions by audience. Anything is there? Then I will announce 2-3 programs.
Sir.
Sir, so firstly, thank you. It was a very good learning.
Thank you,
And
sir.
my question is that epoxy bonding, you told that reinforcement, applying
Yes.
epoxy bonding agent.
Yes.
My question is how to apply the epoxy bonding agent, because there's already reinforcement. You told people will not apply properly. So what is the solution for that?
One method in this, usually this is a problem which is faced in the site. It's a practical problem, sir. It's a very good question. Please be seated. The thing is, especially for the epoxy bonding, what we have a certain time period for that. If you are going to leave it for a longer time, it's going to, the particular, for example, I'll just show it here on the board. I have the concrete here. I have a concrete column here, and this epoxy is, okay, this epoxy is applied onto this. It's applied onto this. Now at the same time, if I see it in plan, the column, this is your column, and this epoxy is applied all around. In ideal condition, what is done? You have the reinforcement around this. You have the reinforcement and you have the lateral ties and the reinforcement. And there you're going to pour the new concrete around this. That is, the new concrete will come here. I'll apply it as a hatch and show it to you. This one. This is your new concrete. This is your ideal condition. What we study, you see it in textbooks, you will get this. But in actually inside, this condition is not so. This is the reinforcement. The shear keys are first drilled in and placed. Then after that, what is done is the reinforcement is placed. What is done, some of the mistakes what we have seen is they take a brush. And they will apply it between this reinforcement. So if I take a brush and apply this strip, it will be only this. The next strip will be shear. There is possibility of what you call some portions being left out. The best would be today what we were discussing with some of my other friends who are into this practice also. What they said is, today's date you get these rollers which are like this. This is you get these paint rollers which you get. The rollers, not the ones with straight handle, no. The ones which are having for this kind of applications. You apply it, you erect the mesh, I'm not saying no. You apply it such that this entire surface is covered to the maximum best. Keys. You have provided these shear keys. You have provided the shear keys. They will hold the concrete. But one thing is, what happens at this interface? There is something, that's what we discussed in the FE model. We wanted to see what happens to the interfacial shear stress. There the slip takes place. Then there is going to be, the load transfer is not going to be efficient. Have I answered your question, sir? That Sir, I think then you must be knowing, sir. The rollers what we use. Sir. Yes, sir. Yes, sir.
Hello.
Yeah, got your point. Sir, for example, what you said now is, I have a footing. And this is your ground level, which is at a which is at a depth of some h. We'll take it. Which is usually we go up to around 5 to 6 feet. We go 6 feet. We go 6 feet to. It depends on the soil type. Let me put it that way. If I have to talk technically, it depends on the soil type. So now what you're telling me is, can I provide a plinth beam here? Connecting, if I have this column here, I have another column here, I have another column here and column here. For this, I have this footing here, have this footing here. Just we'll take isolated footings only. So you're saying if we provide plinth beams here, if they are not existing, on the ground level, but the problem is,
You can do underpinning.
yeah, underpinning, that's what I just wanted to say. Underpinning can be done. But secondly, if there is going to be a sort of distress in the form of settlement, or the cases where you will see that it's basically that, in that case where you have initially identified the initial symptoms of settlement. At that point of time, there is a method. What is done here basically, why the footing areas should be sufficient to spread the load. That is a major requirement of a footing. So that may not be sufficient. So in that case, if I have to enlarge this, maybe I will provide these two footings which are isolated. Now after retrofit, I can combine it together. How do I do it? I have, as you said, exteriorly, if I'm going to do something, as you said, by providing one more beam, as you said, will only happen at the exterior level. But what happens if I'm going to provide, for example, as you said, there, but if this is going to settle down like this, it's going to settle down. Apart from this, when it settles down, it will punch through. That is one more problem which we come across. So because of that, we tend to go for the retrofitting of the foundation itself, so that it is like increasing your width of your foot itself, so that to take a larger load.
Hello.
Yes, sir.
Yeah, my question. Hello.
Yes, sir.
Yeah, if
Yes,
the
sir.
raft, yeah, am I audible? Hello.
Yes, sir. Yes.
If the raft is subjected to uplift pressure, if the raft failure is there, then what is the retrofitting solutions for that?
Okay. You are having a raft.
Yeah.
You are having a raft, and you have a set of columns. I'm just showing a typical representation of it, sir. Okay.
Yeah.
And I will take a slab type of raft. You have beam slab type of raft, you have slab type of raft, as well as you have the ones with drop panels also, which you come across. So I will take a simple slab type of a raft. Is that okay, sir?
Yeah.
So in
Yeah,
this
okay.
case, so for this kind of a raft, what I have the columns here. I have a upward pressure which is acting like this, soil pressure, right, sir?
Yeah, right.
Now I will just draw the deformation pattern of this. This basically, right? So when I have this, you are having an uplift, and there is going to be some portion which has, for example, I will say this portion has got deformed this way. Sorry.
Yeah.
So in this condition, you are asking me what can be done. So in this case, it's not an easy job, but later, off late, I was just working on the same problem with one of my senior colleague. So what was thought over was, his name is Dr. Sridhar. He was a professor at MS Ramaya Institute of Technology. Now he's not been working there, but we are in contact. We keep discussing on these kind of situations. In such a condition, you cannot do much things on the deformed portion. If you are going to try to jack it up or push it down, there will be redistribution of moments.
Yes.
It will cause uplift somewhere else. Right, sir? So,
Yeah, correct.
so in this condition, what has to be looked for is this particular portion of the slab which has got uplifted, as you said. Can you see it, sir? It becomes, you have the column there,
Yeah.
and your raft slab has become this way, right? That's what you were asking.
Yeah.
And this
Yeah.
portion is like this. There is a high chances of this being punched through. This will happen. This fogging will only happen when there is a deficiency in the design of the raft foundation for that particular
Yes.
structure. Only then
Yeah.
that will happen. So in this condition, the retrofit option would be, for the moment, is to increase this slab thickness as a
Yeah.
RC jacket and probably connect all the columns with, if there are no beams, connect them with connector beams
Okay.
to stiffen the raft. You got it, sir?
Yeah, got it. Got it.
So this is basically a deformational pattern where the deformation has taken place, and because of that, now we have to restore it. When you are going to provide the beams, it's not going to be an easy job, but still the concrete cover has to be taken off. That is, for example, I have the raft which is here, and these are the columns. And I will have the reinforcement top mat of the raft. I'll have the bottom mat of the raft, and I have this reinforcement. What has to be done? This concrete cover, wherever, sorry, not the whole, some portion when you are going to introduce a new beam there, such that this beam reinforcement should be welded to this raft foundation, such that you are going to get a connect between the raft foundation and these beams from the behavioral point of view, such that you are going to stiffen the raft. That is one way. The other way is you can provide an RC jacket, but that is also going to, you have to see what is the amount of soil pressure which is acting upward, what is the amount of deformation that has taken place. Based on that, the thickness of the raft jacket, RC jacket, which has been provided for the slab, be decided upon.
Okay. 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 Thank you, sir.
If it's a water table pressure,
Water table pressure, yes, okay.
same situation. Well pressure, if it's water table pressure.
Water table pressure, it depends. First, we have to check what is the depth of the water table there.
No, it is already not, it's under design.
It's under design. And water table is there.
Yes.
So, and there will be one problem. If it is going to, if it has deformed this way, it would have definitely cracked.
It will not be deformed, it will crack.
It is cracked. Now, if it is cracked, sir, if it is cracked now, it is cracked, water will be coming inside. The water will be which is coming inside, which tends to cause pooling of all the basements there if it is an RC. So in this condition, what has to be done first is use, now you're saying is with respect to, it's an under design of the RC raft itself. In that condition, first is you have to assess what is the required thickness which is required from the analysis. What is the thickness which has been provided in site? What is left out? Now you have that, one can decide upon with the consent of the structural engineer and the client. If they can provide that amount of concrete to first restore the structure, then above that you can provide this HP sheets, that is for waterproofing. You are going to provide this membrane, you can provide membrane, or you can go for the spraying technique also for waterproofing. Okay. What can be done best is you take to the, it depends on what is the boundary of your property. In some case, if there is place here, there is some offsets here. As sir said, drill the holes, just suck out all the water. Huh. Okay. Yes. Drains. Huh. Yes. Huh. Okay. Yes.
This system in Tuticorin thermal power plant, where in grace of water, we could drain it. But there are certain areas where you cannot.
Yes. Yes.
And then each situation is different. It needs to be weighted and then identified the way you're going to tackle the problem.
Exactly.
Hence, it is a solution provided the site can admit it.
Exactly.
Acceptance criteria.
Depends on the soil condition also. Yes. 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 And in case if it is a waterlogged area and the soil there is extremely porous, a heavy downpour of rainfall there again will recharge it back.
When he was talking about the settlement, which
Yes.
we have done a very interesting, I'm sure Girish would recall it. In 68 in Bombay, I used to work with Tata Consulting Engineers. Our office was right opposite Siddhivinayaka temple. And we had a 5-story building which was used as a Tata press. Load loading was 15 kilonewton per square meter, 1.5 ton per square meter. And the foundation started settling in a certain area because whenever we do soil investigation, it's more of a sampling. It's not really an entire site what you do it. We put the entire building on the jack, cut the foundation, recast the foundation, and lower the building and connect it to the foundation again. That was in 1968. And it's still working until what I visited last. So when you talk about the risk, you need to identify you're not gambling. There's a definite difference between risk and gamble. When you work towards a plan, the risk can be identified, risk can be addressed to, and you need to be prepared for it. I just thought, and
yes, sir.
This point you notice. May I take another 2 minutes if you don't mind? Okay, there are two things which, when Dr. Guru Prasad talked about, almost thing comes in the terms of as an acceptance criteria. Codes are for a geographical locations and they are not universal. They differ. Like you know it, in IS 456, minimum diameter of bar in column is 12 mm, but ACI 318 it is 16 mm.
16.
So total provision is a very separate issue. Most of the time concrete gets specified. If you go as per IS 456 under those 5 conditions, they get defined from the durability criteria and they are linked to the strength criteria. Like when you look at the concrete M20, M25, 30 or whatever they are, I would rather bring it to your notice one of the buildings in Chennai, which is again ground plus 6 story for software. As per the code requirement, because it's a coastal, we had done it with M30 concrete. The cube test failed. It was 180. Now we took a way out for that. Okay, there are 180 columns per floor. So when I spoke to the project director, I said, we are a time-bound project. That time the software were paid $64 per hour per person. Today it is hardly about 12 or 15. To dismantle it, remove the debris, recast it, a project is going to delay by 3 months. You will calculate your loss because he talked about cost. $64 was a hell of a big money per hour per person.
Per person.
So we took a view, we reanalyzed it, and we found that to me, M17 grade concrete is also more than adequate from the strength criteria.
Strength criteria.
and we didn't dismantle the columns. We gave a coating on the column to stop the from the durability criteria of ingress of moisture, either for the carbolic acid coming in or the chloride ions coming in. So quite a few times you really sit down and talk about what are the acceptance criteria, because the cost, unlike earlier days, cost was only for cost of construction, but today it's a return on investment. If I get my investment earlier,
Exactly.
I'm willing to pay for that. So there are quite a few situations when we talk about repairs, when we use NDT. NDT accuracy is only 20 to 25%.
Yes.
Plus or minus.
Plus or minus standard deviation.
Right.
True, sir.
Now, Ujjwal Kumte, when he presented in ICI 22 or 21, he talked about very well. He said FCK plus standard deviation.
1.65.
And when you get it, so it should be plus or minus. So when you do an NDT and when you get a result, you accept minus also, need not be plus for repairs.
Exactly.
So there are various views when you get certain data. And when you infer from that, I'm for the project, I'm the interest of the client, not sacrificing this stability, safety, durability. You take a call and please go ahead and violate codes. Codes are not Lakshman Reshas. That's my suggestion.
Thank you, sir. Any more questions?
So,
No.
sorry?
Sir, can you hear me? I'm
Yes.
online.
Yes, sir. Please.
Sir, actually, now if we are doing the carbon fiber wrapping or GFRB, any fabric type of wrapping,
Yes.
so you have mentioned up to 2 to 3 MPa strength we can do it. I think you have mentioned something like that. Maybe if I'm wrong, just correct me on that way.
2 to
So,
3 MPa, no. 15 to 20% increase in the
15
strength.
to, okay,
20%
up to
increase
50.
in the strength. In the strength.
Okay, okay.
Not 2
So
to
up to
3
50.
MPa.
Okay, 15 to 20% in the strength. Up to that, we can use the wrapping technique, right?
Yes.
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 So, and one more thing is like
that is based
after,
on your loading conditions, sir, and the
okay,
distress which has taken place. If there is excessive cracking and the portion, what you did see, if the reinforcement has bulged very badly, and it also
okay,
depends on the spacing of, if it is in the case of a column, the spacing of the lateral ties in the column, and
okay,
if it's in the case of a beam, it is the spacing of the stirrups in the beams. You have to
okay,
look into that also, and then take a
okay,
call on that. It is not
okay,
like in the case, if you are seeing that it's only an increase in the concrete strength. You have checked through NDT, as sir said, you have done ultrasonic rebound hammer, and you have checked,
yes,
and you didn't find it so convincing. You go for core test, and from that you have found out that okay, it is less because it's at in situ at a few places. Because you cannot take cores at many places too. So at the
yes,
same point, you come to know that the strength is, what I gave an example is 25 Newton per mm square should be your concrete strength. But
yes,
you have gone to, you have got somewhere around 21, 22. You can
yes,
definitely go for wrapping. But if you
okay,
get a strength close to around like 15 or 14, you have to
yes,
think twice when you go for wrapping. You have to see how much is the reduction in strength. Because at that
okay,
point of time, sir. Yes. Wait,
sorry, sir, not audible, sir. Sorry to interrupt, not audible.
What I said was, when Dr. Guru Prasad talked about M25 concrete giving you 21, etc., what
Yes,
it
sir.
really means in terms of design, as far as IS 456 is concerned, and it's universally true. You use for the actual stress, FCK by 4 is a permissible stress. For bending, you use FCK by 3 as a bending stress. So in a 20, you're using only 5. In a axial stress, you are using only 5 in M20 grade concrete. And M20 grade concrete bending, you are using only 7. Now, even if I were to be at 21 instead of 25, what it would mean? Nothing. I will not repair it.
As sir said, that is the margin is there. But when you are going for
Understand.
when you are going for upgradation, in case of structural evaluation, when you go for, as a structural engineer, if you are going to give your report, if you a
Yes.
person they are going for a repair, so which
Yes.
one would you suggest is this? That's what I want.
Understand, sir. Sir, and one more question. Sorry.
Yeah.
What is the test post doing the mic, even the jacketing, steel plate, or any wrapping, strengthening method? What is the correct
Post
test
retrofit,
method?
post
Yes,
retrofit
post retrofit.
testing. Post
Yes.
retrofit testing method. Very good question. Is now you have done FRP wrapping. After
Yes.
you have done FRP wrapping or you have done RC jacketing, the only
Yes.
thing what you have to check is for any form of, in case of FRP, you have to
Yes, sir.
check for any form of delamination which takes place. How do you get to know if there is a delamination? Now, if it's a
Yes, sir. This
column,
is the question I
yeah,
wanted to ask. What is the
if you have
process?
if you have a column, if you can see it, sir, if you this is a column and you have applied
Yes.
this as the this is the jacket, this is in the cross section, okay. Now,
Okay.
if you are going to see this is perfectly done. Now there is
Yes.
one method what you can do. What people have done is through this ultrasonic scans. Through the
Okay.
ultrasonic scans, you put the,
Okay.
definitely there is a, what you call, the ultrasonic pulse velocity is used only on the concrete. But now you may be asking me, what is this? I have put an FRP there and you're checking for ultrasonic. So what
Yes.
happens
Yes.
after you have put the FRP, let it be CFRP or GFRP, you have put it with a certain epoxy, right? It would have
Okay.
had some density there. Now for this,
Yes.
when it is perfectly bonded, you would have a, what you say, pulse which goes and you will get a pulse time, including the thickness of the particular FRP wraps which you got, you call it as some dt. So the velocity is dt by t. Now you just have a measure of that. You don't please what you say, compare it with the codal provision to see if it is 3, 3.5 or 4, 4.5. No, that is not what you're
Okay.
going to use for. Use check this for perfectly bonded case. Now there is a case here which it has got debonded here. See, you can see this here, sir. It has got debonded here. And there is an air
Yes. Okay.
pocket. This is an air
Yeah.
pocket, air
Okay.
void, what we call it. Here you are going to place a probe here. You have to see to it
Okay.
that it is in perfect correlation. So you get a
Okay.
certain value V here, V1. When V1 is less than V in certain conditions, if it comes close to it, if it comes, is not much, if V1 is very, very, very close to V, some
Okay.
variations will be there in the readings. Variations will
Yes, sir.
definitely be there in the readings. If it's very close, it's fine. But if the variation is significant, then it means to say
Okay.
there is a condition of delamination which has taken place. And one more thing is, by visual inspection also, after some time, if you start seeing some kind of bulges, it means to say that
Okay.
that is a case of FRP delamination. Now, in case
Okay.
of RC jacketing, if you ask, what will happen?
Yes.
If I have an RC jacket, don't please place
Yes.
this probes using
Okay.
ultrasonic. You have to
Okay.
just check in case if there is going to be a particular slip. If this is your column and this is your RC jacket which is being placed. Now, if this RC jacket which I'm hatching here, okay,
Okay.
shifts down,
Yeah.
if I'm drawing it a dotted line, if it slightly, there is a shift, there is a slip, what we call it, there is a slip,
Yes.
there is
Yes.
definitely cracks which will emerge on the surface. It will come
Okay.
up because if you have shear keys there you will
Okay.
get radial pattern of cracks which will come there. If you have it in the outer part, you would have had the shear keys inside somewhere there. If it has
Yes.
slipped, you will get
Yes.
cracks. You will
Okay.
get cracks.
Okay.
It may not be radial also, it depends how the particular shear keys are provided. If they are provided deficient shear keys, there would be slip which can take place. Or second, the thickness of the RC jacket provided may not be sufficient or the design may not be sufficient. Because of that also the cracks can emerge. That is one mode of
Okay.
finding it out.
Okay. Sir, one last question.
Yes, sir.
And during the jacketing, especially the column or jacketing, what I learned from the earlier sessions, maybe outside also,
Yes.
they asked to provide us a prop and make it as a, the loading should be very, very minimal during the jacketing process. Is it necessary?
Not necessary. No, it's not so. It's not so. No, I didn't get your point. Loading on what?
No. We are doing a jacketing for a column. Example, we can take a jacketing for a column,
Okay. So
and
this
we are
is,
yes,
this is a column and I'm putting the jacket around it here. This is
yes, sir.
the formwork I put around the column.
Yes.
Yes, please tell me.
So now they requested us to put a prop to distribute that column's load to the slab.
Fine. Okay, got
So
it.
that to make
So
the
see,
column.
wait, sir. This is your beam which you have, and this is your column which you have. Am I right?
Yes.
And this is your slab which you have. Am I right?
Yes, correct.
You have it like this. Now you want to jacket this column.
Correct.
This is, you're saying you want to provide the props here. You want to provide the props here near the column.
Yes.
Next to it.
Yes.
So because it has been jacketed, but has there been any distress in the beam or slabs, or has there been any deformation there?
No.
So you can take.
It is just to make the load carrying capacity of the column to make it very, very minimal.
It will not work. It's not necessary.
Okay.
It's not necessary. This is not necessary because the column itself is there. You are providing the jacket with the formwork that itself forms as another support.
Okay.
Is that clear, sir?
Yes.
I think you need to understand when you remove the props, the deflection
Yes,
has
sir.
already taken place.
Correct. Yes.
Normally, of the total load, is 50% comes from the dead load. And the deflection would have taken place. So irrespective of anything, the load transfer is only 50% of the load that it has been designed for. So by your providing prop, unless you jack it up and remove upwards, you cannot reduce the load. So it's a myth providing a prop. It doesn't mean anything.
The prop should be only provided if there is any distress in the beam or the column and if there is any sagging there and you are trying to restore the beam or the slab there.
Okay,
You have to jack it. Yes. That's a temporary measure only, but not for the column.
Understand, sir. Excellent, sir. Thank you so much.
Sorry, because of paucity of time, we cannot take more questions, but our YK group process sir is there. I am just sending a message. All the members will be given their email ID. They can post the questions. I would like to say, why not Guru Prasad for all the problems? Definitely answer. And again, why Instruct has not used the Guru Prasad service till date? I am just thinking, but we are very happy that today wonderful session he has taken us. And please, all other members also should take lead and come forward to give lectures in Instruct, which would be a benefit for this society and engineering fraternity. On behalf of Instruct and on behalf of all of you who gathered here for the wonderful session, I request Ulas Prabhu sir to give a memento for Guru Prasad sir. Sir, thank you very much for providing your valuable lecture, and we were very happy. Please come, sir.
Thank you, sir.
Thank you. Thank you very much. I request all the Instruct members to give the same support. There is one small announcement is there. After that, we all have a group photo.
Very kind of. Thank you.
Thank you, sir. Thank you very much.
Request everybody to give him a big applause. He deserves his country. And I think all of us are proud of him, and very nice to know that he's gone into almost 2 hours, 2.5 hour session. And great, sir.
Sir, I would like to apologize to everyone for the delay also, if any. So all the members present here
No, sir.
and online also.
Because we are happy that everybody is questioning. Still, we have a lot of questions. We only
Okay.
force not to ask. Now,
Sir.
again, Instruct is conducting a 40th batch of building construction and supervision course on 12th of August. I request all Instruct members to support this event by sending messages to all your friends and students, whoever it is there. And again, please take your seat.
Sir.
And in Goa, we are doing one more program, 2 days special program, Earth Retaining Structures, joint program with Goa College of Engineering, 24th and 25th of August, Thursday and Friday. Those who are in Bangalore, you can see the retaining structures is very, very important when we look at the infrastructure services. In the last month, we have seen KR Circle underpass, somebody has dead because of heavy downpour, where infrastructure services are very, very carefully dealt, designed and maintained. And this juncture, we are conducting this 2-day program. Please support these programs with sending the messages of Instruct programs. And also my sincere request is we are starting a internship program for 6th semester students. Normally 6th semester students are going to internship on 12th of August to September. So on the same dates, Instruct is also conducting internship program. Whoever comes to your notice, if they are unable to get internship in any of the bigger companies, Instruct is here to give them all-round training. Like, we have offline seminars, online seminars, and site is a blended. We use all our Instruct members. I also request whoever is there in the online mode and offline mode to send their mails regarding their acceptance and their offerings and their interest, expression of interest to give the lectures for these programs. We will definitely take into account. And also, the Instruct is running because of your own love and affection. Please continue the support. And every time we request all the participants to write mail about the quality of the program so that we will improve our qualities. So today we had a wonderful session. Once again, I thank Guru Prasad sir. Thank you all. Thank you all and good night.
Sir, I just want to make one small.
Please, sir. Please, please.
I want to thank Instruct and all the committee and the chairman and all the members of Instruct and everyone present for today's session. I thank all. I just want to say one word regarding the profession of civil engineering, because there is a call saying that there is a decrease in the number of seats everywhere. But I want to say one thing to all the civil engineers. If you are knowing your field well, especially in the field of construction, today, especially in NDT, people can work as NDT engineers. There are no civil engineers who can go out of job. That is one thing I can assure you. Civil can never, no civil engineer can be without a job as such. So if you are knowing your domain and if you want to excel in it, there is ample amount of opportunities, only you will have to look for it. Thank you. All the best. Yes.
That is the message we have to send it to the. Always we should say this.
Yes,
civilian is the lion in
Thank
the
you, sir.
forest. Thank you.
Sir. Thank you, sir. Thank you. Thank you, sir. Thank you. Thank you, sir. Thank you, sir.
Sir, can we get the Dr. Guru Prasad's phone number, please?